we're looking at types of vector. So let me start off with a small animation. So we have, first thing we have is something called a zero vector. Second thing is a unit vector. First of all, understand what's the word unit. Try to recall that. And now apply the concept onto this. Think, why is this unit vector? Why is it called a unit vector? Okay, next type of vector is co-initial vectors. Co-initial. Co-initial. Initial. The keyword here is co and initial. Next is collinear vectors. Collinear vectors. Collinear. Co-initial. So what is the conclusion? You guys have a basic idea of what are the vectors, why are they called whatever they're called. Let me explain this. Vectors whose initial and terminal point coincide. That is, it starts and ends at the same place. But why do we need this? The very basic question is, why do we need this? When I was studying, I thought, what is the point of that? Well, when we're doing vector operation, okay, vector A, when it's vector A is equal to vector B, and we are subtracting two vectors of same magnitude and direction and all of that, we end up with this answer. Right? The answer is a zero vector. Case 2 also is a similar thing. We have two values which are equal and opposite. And this is a particular operation, whatever the operation being. The answer over here is 0, right? Because we are adding and subtracting values which are equal and opposite in magnitude. Now, velocity of stationary object is a zero vector. Position vector of a particle lying at the origin is a zero vector. So what is the position vector? That I'll be talking about. Velocity of stationary object, that you guys can understand. An object which is not moving has a velocity which is 0. Right? Okay. Next thing is unit vector. So you could see clearly over here, unit vector are of length 1. It can be 1 centimeter, 1 meter, 1 kilometer, doesn't matter. It can be 1 kg, 1 Newton, so on and so forth, not kg, 1 Newton, so on and so forth. So basically any direction, but the magnitude has to be 1 unit. It can be related to any quantity, doesn't matter. It's generally represented as a vector. In place of an arrow, we have a cap. Yes, a cap. Representing that it's a unit vector. It's very important. See to that you guys don't miss this. We don't use an arrow, we have a cap. Okay. Next, co-initial vector. Co-initial means two vectors which starts at the same point. There's the same initial point that you guys saw. Right? It's a very clear-cut example. Collinear vector. Collinear. See what's collinear? Linear means what? See, initial means starting, start. Right? That's what initial means. Linear means what? Sameness regarding the line. Okay. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitude and direction. All this will not matter. Okay, so I think I have few more types for the same video, that is. Let me check. Next, we have equal vectors and negative of a vector. Okay. 1 minute. I do have the animation for this as well. Small animation. So those two are equal vectors. Why are they equal vectors? Can you think? Yes, the direction and the lengths are the same. Negative vector. Why are these two negative vector? Yes, because the directions are opposite. Right? That's a very fundamental thing. Of course, even the magnitude has to be, and the magnitude has to be same. Not even the, and the magnitude has to be same. So let me put it across this way. Two vectors A and B are said to be equal if they have the same magnitude, same length, and the direction regardless of the position of its initial vector. So initial point can be anywhere. They can start off anywhere, but their magnitude and direction, if they are same, they are equal vectors. How do you represent this? Vector AB is equal to vector DC. Okay. Now, negative of a vector. We have a vector whose magnitude is the same while the direction is opposite. So how do you represent this? Well, if we have a vector AB, then since the magnitude are equal, but the direction is different, so this is how we would end up with writing that they are equal but in opposite direction. Equal in length and opposite in direction. Okay, it's a very simple thing, simple set of concepts, right? So you guys have to write unit vector, so you guys have to write. There's no option for that. Everything else is very simple. It's left to you guys if you want to write it or not.